Okay, now we're going to take a look at some data. And this is data from this website, SeanLehman.com. And notice that this there's no, this isn't a link, it's just the URL. Let me just quickly show you how to turn this into a link. So we'll open, just copy this, and you can insert a hyperlink. And just paste it right here, and it's going to be taken as a URL. You can also link to parts of other notebooks to share that later. But here now, this is active link. Click here, and one of your web browsers will go to the site. And this is the this has a lot of data. There's a download section, and I downloaded the comma delimited version, and that's what I'm using today. Okay, so if you're going to use it with Mathematica, you'd want the comma delimited version. There's a lot of data out there that's available like this on all kinds of subjects. So what I did is I'm not going to work with the complete data set right now. I'm going to use a smaller file that I extracted from a large file. And first I'll do is set the directory to the notebook directory. And let me look at the files that start with SOX. There is one. It's called SOX1967.csv. So this is information just on the 1967 Red Sox. 50 years ago at this time. They won the pennant for the first time in a long time. So we're going to import this file, and I already have the file name, and I know it's in the directory I'm currently in, so this will work. I'll call the result SOX. Notice I'm not, if I put a semicolon, leave the semicolon out, I'd see the whole list. It isn't huge, but I don't want to see it immediately. We'll take a look at it in a second. So SOX is the data. So let's take the first 3 entries in SOX and take a look at them. So as with many data sets, the first line is headings. And after that are individual player statistics. So I'm going to have the player stats be the player information, and that's the rest of SOX. So rest is everything but the first line. And we're going to refer to the headings. So I'll say headings is the first of SOX. Okay, so I didn't display player stats, I did display headings. I didn't put a semicolon. So you can see that this is a list of headings and indicating what each item in the lists represents. It's I find it's convenient to do something like this to be able to work with this data. Now the length of headings, I'm not sure what it is, but if I take the numbers from 1 through that length, create that range, followed by headings, and create a list consisting of those 2 lists, you get this. And this sort of gives you a number, lets you associate every item with a number. So the 12th item, for example, is the number of home runs hit by the player. So in fact, we can extract from player stats all the home run numbers. Or we could do, instead of home runs, change this up to 11, and we'd see the triples. And going back to home runs, if you want to know how many home runs Red Sox hit that year, this is in the regular season, just do total. It's 158. It's a small number, I believe, compared to this year. So what I'm going to do is I'm going to look at one particular statistic that isn't here. If you look at the all of the data, there's certain information can be derived from this basic information. For example, the batting average. I've got some text here that describes these statistics. I'm going to concentrate on batting average. I have a bunch of other things. If you're interested in baseball, you can read it and check it out. I'm going to just concentrate on the batting average, which is very simple. The batting average is determined by taking the number of hits, which is item number 9 in each list, in each player line, divided by the number of at-bats. So it's item set 9 divided by item 7. Okay. So let's just take the first player. Okay, so player stats 1 is the first player on the list. And I'm going to take the 9th item and divide that by the 7th item. And these are integers, so you get a fraction. I want to use n to get a real number, and it's customary to have 3 decimal places. So yeah, the batting average for this first player on the list is 291, which is decent. We'll identify that player in a minute. So there's other statistics like on base percentage and so forth. I'm going to skip. But now let me go down to BA. I'm going to define BA to be the batting average function. So for any one of the lines in this data, if we take a line and put it into the input section, input slot of this function, okay, which is here and here, this function takes the 9th item and divides the 7th item into it, and does exactly what we did above. It takes n, takes the 3 decimal place real number from that. So this computes the batting average for any particular line in our data. Notice we're taking a complete line, not just 2 numbers, but we're taking the 2 of those numbers out and computing with them. For other more complex statistics, you have to take more items, you can see, for on-base percentage. But I'm going to just concentrate on batting average. So evaluate this BA function. So what I'm going to do is I'm going to map the batting average function over player stats. Now there's one glitch. One player, I think it was a pitcher, only was with the team for a short period of time and never got to bat. And so if you compute the batting average for that player, you divide by 0. And that's where this indeterminate comes in. I'm not going to get complicated. You could define this function to be a little bit more complex to check to see if the number of at-bats is positive. If it isn't, set the batting average to 0. But I won't bother to do that now. Okay, so what I'm going to do is I'm mapping the batting average function over the player stats. So here's a list of all the batting averages. In some cases, you get more than, well, you get 3 significant digits. So normally you would display, for example, this says 0.091. Don't worry about that either. Of course, this doesn't tell us what the players are associated with the batting averages. What I'll do now is refine that we have this map function. And instead of mapping the batting average over the player stats, I'm going to map this function that takes the first item, which is it isn't the name, it's the player code. I'll talk more about that in a second. But the player code followed by the batting average. Okay, so we get this. Okay, so if you're a baseball fan and you're remember 1967, I'm sure most of you don't, you might recognize a few. Tony Conigliaro, for example, local kid who was doing very well until he got beamed. Had a batting average of 287, which is pretty good. Way down at the bottom, Kyle Yastrzemski, who won the Triple Crown and was Most Valuable Player. He had songs named about him. Batted 326. That was his best year ever. Okay, so of course you have to be a fan to be able to figure out what these names are in most cases. That's going to be our next objective, and it's to translate this, and I'll show you how that's going to be done. But for now, we do have the batting averages for each of these players. This pitcher, Ken Brett, is the one who didn't bat at all. Earlier, we generated a list of players and batting averages from the 1967 Boston Red Sox, and the problem was that the names weren't there. They were the player codes for the players, and I'd like to use an association to be able to display the real names of the players. So we're going to create an association called real name. So start by making an empty association. Now, if it weren't for the fact that there were thousands of possible baseball players, and there were quite a few even just among the Red Sox in 1967, you could do something like this. So real name is the code for Kyle Yastrzemski, and set that to be the name Kyle Yastrzemski. And there's Jose Tartabull, you could do that. So we could evaluate these two, for example, and now real name is this association. Now, really, we want to be able to do this for more than just the 1967 Red Sox. So what I'm going to do is I'm going to get into Baseball Data Bank files, and I'm going to find a file that is going to be able to let us generate an association for all players. Within this notebook directory, we have a directory called Baseball Data Bank, and actually there's a subdirectory of that called Core. And it has all these different files listed. And the one we want is called master. It's in here. So I'm going to import that. Now, obviously, I've got a semicolon at the end. I'm not going to display it because it is quite long. And it turns out the length is almost 19,000 items. So let's just look at one. But we create a list of the 24 numbers from 1 to 24. Then the first of master, which is the headings, and then pick out Kyle Yastrzemski's as an example. And you can see that the items in master include the code, birth year, city, country, state. Finally, way down in the 14th and 15th entries are the first and last names. And in fact, there's even his full name, a lot of other information we're not going to use. So what we're going to do is we're going to take for every one of these rows, and this is what you see for Kyle Yastrzemski is one example of a row. For each one of the rows, we're going to apply a function, a pure function, that does this. It takes the 14th item, which happens to be the player's first name. Way down here we see the first name, the 14th item, and we concatenate that with a space and then the last name, the 15th item. So this generates the name of the player. We associate the code, which is the first position, okay, first position for each player, is the player code. Okay, we associate with each player code that full name. And we map that pure function over the rest of master. So we do this. That doesn't take hardly any time at all. Okay, so let's test this out. We have the player stats, and we're going to map the real name over the first item in player stat. Okay, so we're going to map this real name over the first item, which is the player codes. And you can see that you get a list of names, and these are the players who were on the roster of the 1967 Red Sox. Now you can do that with the original expression we just looked at, which was if we could map over player stats, first the real name, and then the batting average. Okay, so instead of seeing what we saw up here with batting averages associated with player codes, we have batting averages displayed with players' names. Let's now that we have this real name association working, let's try it with something else. What I'm going to do is I'm going to import a much larger file called batting.csv within the baseball data bank, and I'll call that all batting. That took a couple seconds. And now what I'm going to do, let's just look very quickly at what all batting looks like. I'm going to just take all batting. Now let's just pick a random number. Let's pick a 234th item. Let's actually look at how many items there are here first. What's the length of all batting? Okay, so there are 101,000 items. One of them is the 234th, and what it contains is a player code and a lot of other information. Now, I won't get into how I decipher it. Do the same thing as with the other file. There's a heading to this, to all batting. It's the first item. And based on the position of the information, what you can do, map over the whole file, first the real name, the list consisting of the real name. Second thing is the year. Now this is actually, each of these lists here is the information for one player in a given year. And then map, the third item is the number of home runs, which is the 12th item, divided by the number of hits in all, the total number of hits, which is not item number 9. The third item is the number of home runs, which is the 12th item, divided by the number of hits, which is the 9th item. So mapping that pure function over all of the items in all batting where the number of hits was at least 50, because we want to rule out players that didn't play that many games or didn't have that many hits. We select from them, map over that list using this function. Okay, so you get things like a name like Mark McGwire, 2001, and this number, which is roughly 51% of the time, a hit he had was a home run. And what you do is you do that mapping, and then you sort so that the last item, the third item, this percentage, is sorted in decreasing order. And finally, take the first 20. So again, there's a series of steps that are taking place here. You pick only the player seasons where the player had at least 50 hits. You map this function, which produces the name, the year, and the home run percentage over those players, and then you put them in order and take the top 20. So here's the list. I'll reevaluate this, demonstrate that it still works. And you can see that Mark McGwire has had a remarkable run